Good morning. Let's continue engineering mathematics course with the topic of integration. So integration, these are just some revisions on what you have probably seen or learned before you come to university. So for integration, we have indefinite and definite integration. So for that indefinite integration, there are no limits. So you don't put any limits to the integration. Thus, you need to add a constant of integration at the end of the integration. So in this case, for example, if you integrate the function f of x with respect to x, then you may get another function g of x plus with the c. So here c is the constant of integration. Whereas for definite integration, you have limits. So you are integrating the function from a to b. For in this case, for example, here you are integrating the function f of x with respect to x from x equals to a to x equal to b. Thus, after integration, you will get a new function g of x. Then you evaluate the integration. You substitute x equals to b and you substitute x equals to a, then you get a number. So just to recap, f of x function of x is the integrand, the one that you are integrating. G of x is the integrated function, and the dx here is the variable with respect to which we are integrating. So in this case, if you are integrating the functions with respect to x, so you put dx. So there may be, you may use different variables, u or y and so on later in this course, but yeah, just pay attention with respect to what variables are you integrating your function with. Okay, let's start the integration topic with integration by parts. So this integration by parts, it can be applied to a wide variety of functions, as you can read in this slide. And it's particularly useful for integrands involving products of algebraic and transcendental functions. So what is a transcendental function? So algebraic functions are the normal functions with addition, minus, division and multiplication, but these transcendental functions are the everything else, like the logarithm, the natural logarithm or ln, cosine, sine, like all the other functions except for the plus, minus, multiply and divide. So those are called the transcendental functions. Okay, going back to integration by parts. So if f and g are differentiable functions, then the product rule yields. So you've seen this. So if you have this product of two functions, f and g, so if you want to differentiate the product of this function, you would you would keep fx first, and then you differentiate the g, and then plus with, you keep the g as it is and you differentiate the f. So in the form of indefinite integral, so if you just reverse the role here, so right, so if you integrate this part, okay, with respect to x, you will get the original functions of f and g in terms as a function of x. So in this case, if you rearrange this this equation here, okay, so if you rearrange this equation here, you get first of all you need to separate this term. So integration of f of x, g of x dx, plus the integration of g of x f prime x dx equal to product of fx gx. Then if you just rearrange this equation that is separated, so you put this as the subject, and then you already have this at the right hand side, then you move this to the right hand side, then you get this whole thing here, which is the formula for integration by parts. So let's make our life easier. We always want to make our life easier. So let's put fx as u and the gx as v. Okay, so then in terms of u, it's easier. So when you use and you have u equals to fx and v equals to gx, then if you differentiate u with respect to x, then you have du equals to f prime x dx, and similarly dv equals to g prime x dx. Thus, the previous formula for integration by parts becomes u dv equals to, integration of u with respect to v equals to the product of u and v minus the integration of v with respect to u, du. Okay, so this one is easier to remember compared to, fx prime, gx, all those, a lot of brackets. So, but it's the same formula actually, it's just a simplified version. So you can also do definite integration with integration by parts when you just put the limits a and b in the integrals. Okay, so originally this was your formula, right? So this was your formula, original formula. So if you just put the limits a and b, then you just have to substitute the values of x with a and b and put in the limit so you don't have a constant. Similarly with the formula that is in terms of u and v, so if you have the integration of u dv, so you just put a and b here as the limit, so the product uv, just substitute a and b, and similarly the v du, just put the limit a and b when you integrate later. So before we go to the first example, I just want to show you these trigonometric identities, which I believe you have seen it before. So just a recap, so we're going to use some of these identities to help us do the integration in the examples. Okay, so example 1, integration by parts. Find the integral of x sine x dx. Let's use both methods. So actually we're using the same formula, it's just that method 1 is using the original equation of the formula, the fx, gx, and the primes and the dx. Whereas method 2 is the u and v and du dv, right? Using the formula with the u and v terms. So let's do that example. Okay, so for this example, integration of, let me change the color of my pen to black. It looks better, I think. So integration of x sine x dx. So using the first form of the formula, so we need to define what is fx and what is g prime x. So in this case, our fx is x and our g prime x is sine x. Okay, so when our fx is x, so our f prime x equal to 1. And if our g prime x is sine x, then our gx is the integral of sine x, which gives us the minus cos x. So putting these terms into the formula, so you have the original formula, just to recap again. Okay, this is the original form. Okay, so you already have all these terms up there, so you just substitute it. So so this x sine x dx equal to fx is x, gx is minus cos x minus integration of gx. So gx is minus cos x, f prime x is just 1 dx. Okay, so you have here x minus x cos x, then you integrate the minus cos x, you shall get sine x plus the constant of integration, because this is a indefinite integral. So that's it, using the first form of the formula. Right, so for method 2, we're going to use the formula in terms of u and v. So integration of u with respect to v equals to uv minus integration of v with respect to u. So our original problem is to integrate x sine x with respect to x. So now our u is x, so du equal to 1 dx, and our dv is sine x dx, so our v is negative cos x. So putting this into the formula there, then we get integration of x sine x dx equal to u is x, v is minus cos x, minus integration of v minus cos x du. Du is just dx there. So you just do the same thing. Yeah, so you got sine x plus c. It's basically the same thing. It's just that this formula in terms of u and v is easier to remember. Right, so let's move on to the second example, example 2, where we're going to use trig identities to solve for this integration problem. So you want to find the integral of sine to the power of 5x and cos squared x dx. So these are the steps given here. I mean, I have laid out the steps. So actually this example is available in your lecture notes. Let me know if you don't have your lecture notes and I will share it in Spectrum. So first you need to convert the two appropriate trig identities and then use the u substitution, perform the integration and then substitute with the original terms, i.e. the sine x and the cos x. Don't just leave the final answer in terms of u substitution. Okay, so let's do the integration following the steps. Okay, let's write down the question again. We want to integrate sine to the power of 5x cos x squared with respect to x. So here, which trig identity that you may want to use? So I think the useful one here is the sine squared x plus cos x squared equal to 1. So here, if you want to substitute cos squared x equal to in terms of sine x, then you will be left with just sine x. So it's going to be difficult for you to manipulate the integration. Okay, so what we're going to do is we're going to break down the sine to the power of 5 into sine 4 and sine 1. I mean, okay, let's just go through this. Okay, so take this term here. So sine 5x cos squared x, we can break it down to sine to the power of 4x cos squared x and sine x. Then we can take this as sine squared x squared cos squared x sine x. So here, this sine squared x here, you can substitute using this trig identity. Then you put this as 1 minus cos squared x, the whole thing square, then cos squared x sine x. So now let's use the u substitution. So this takes a lot of practice. Maybe it's not as intuitive when you first came across or when you haven't been doing it for a long time, but it just takes practice. So let's put u equal to cos x. So du is equal to negative sine x dx. Okay, so now when you have this u in terms of cos x, then you can put it in terms of u. Right now, our terms becomes okay. We want to integrate 1 minus u squared, the whole thing squared. Then cos squared x is u squared. Then sine x is, from here you get sine x equals to well, dx actually, because you will have the dx in the original integral. So sine x dx equals to negative du. So you just put negative du. Then from here you can integrate it much easily. Okay, so you put the minus out here. So you integrate, and then you have u squared, and then inside here you have, I mean, you just expand the inside term and du. So expand everything. Okay, then continue. So from here you can easily integrate the term. So let's just continue. So when you integrate, you have minus everything, u cubed over 3 minus 2 over 5, u5 minus u7 over 7. Everything plus the constant because it's an indefinite integral, but don't forget to give your final answer in terms of the cos and x back. So initially you put substitution as u equal to cos x. So put it back into the equation. So there goes 1/3 of cos to the power of 3x plus 2 over 5 cos to the power of 5x plus 1 over 7 cos 7x plus the constant of integration, and that's it. I think if it's easier to integrate it if you use the appropriate trig identities and use substitution, then only you will get to this point. Okay. Okay, so by right, this is an exercise for you to practice using trig identity to integrate the given trigonometric function. So by right, this if it's a physical class, I would go around and see how you do it. But here, I hope you pause the video for a while, not just go to how I do the solution. So I hope you pause, then only proceed to see how I do the solution. Okay, I assume you have paused the solution. So, I assume you have paused the video and tried to solve this problem on your own. So here we want to use a useful conversion into trig identity. I think here the useful one is secant squared x equal to 1 plus tangent squared x. Same thing here, you don't want to be converting everything into just one term, because you would have a difficult time to manipulate the integral and derivative. You want to keep both terms, secant and tangent, in the original integral. Okay, so here let's substitute u equal to tangent x. So here in this formula, in the given problem, you would have, since u equals to tangent x, then tangent squared x, you will have u squared. Okay, and then coming back to u equals to tangent x, du equals to secant squared x dx. Then you can see that this secant squared x here can be broken down into secant squared x, the whole thing squared. So you want to do that, okay? Secant squared x times secant squared x dx. Okay, let me just try to do it in tangent and secant first, not jumping too fast. Okay, so tangent squared and then secant squared also equal to 1 plus tangent squared. So 1 plus tangent squared x times secant squared x dx. So now if you look at the u substitution here, I hope it's becoming clear to you that this tangent squared x you can put in terms of u squared, and then 1 plus tangent squared x is 1 plus u squared, and then this whole thing secant squared x dx is du. Then it becomes easier for you to integrate. So you expand u squared plus u4 du, then you get u to the power of 3 divided by 3 plus u to the power of 5 divided by 5 plus with constant of integration, but do not stop there. Substitute back in terms of x. So your final answer should be 1/3 of tangent to the power of 3x plus 1 over 5 tangent to the power of 5x plus c. Alright, that's all. Did you get the same answer when you pause the video and try it on your own? I hope you do. So this slide is just showing you some useful formulas and trig identities which you can make use in the integration. So this is also available in your notes. Okay, so why do we do trigonometric substitution? Because it allows us to integrate functions that involve square roots relatively easier. So let's see an example here. Okay, so if we have to integrate this function x and the square root of a squared minus x squared with respect to x, you can use u substitution here. Let's say if you put u equal to a squared minus x squared, then you differentiate u with respect to x, so you have du equals to negative 2x dx, then you can put this x dx together. X dx equals to du over -2. Then you can simply, just put this, and then the x dx becomes this negative u over 2. Then you can easily integrate this. But if you have this kind of example here, where you have the function is this only, no x in front of the square root, it would be more challenging to integrate this function without the use of trigonometric substitution. So what you want to do is to change the variable x to theta by the substitution of x equal to a sine theta. Okay, depending on what would be more useful for you to use. Okay, not just x equals to a sine theta, but in this case, if it's a squared minus x squared, everything is square root, then you may want to use x equals to a sine theta. So when you have this, it's easier for you to do also. So from this term, you can get dx equals to a cos theta d theta, right? Okay. Right, so like I said, the substitution of x in terms of theta depends on the expression you are given. So in previous slide, if you are given the square root of a squared minus x squared in this case, then it's easier for you to substitute x with a sine theta, but you have to have a range of theta that works for this substitution. So in this case, theta should be between negative pi over 2 to pi over 2, and then you can use the trig identity of sine squared x plus cos squared x equals to 1. But if you're given a squared plus x squared, then it may be more useful to use this. It is more useful, it's not maybe, it's more useful to use this substitution and this identity. And then if you're given this function instead, x squared minus a squared, the whole thing square root, then you want to use x equals to a secant theta, and you want to use this identity for substitution later on. Okay, so you don't have to memorize all of these, since it's open book now that everything is online learning, which is good. So you don't have to panic on which trigonometric substitution you need to use. Just refer to this table if a question appears that you need to use it. Okay, let's do example 3, where we will use the trigonometric substitution for integration. So you are asked to evaluate this integral square root of 9 minus x squared divided by x squared with respect to x. So these are the steps laid out that you can follow. So we substitute this x with 3 sine theta, with the theta ranges between minus pi over 2 and pi over 2. Then we use the inverse substitution rule to integrate with respect to theta. Then you need to back substitute into the original variable x. So why don't you pause and try to attempt this example on your own. Right, so assuming you have paused the video, so let's do that. Sorry, let me change back to black. So we want to integrate this 9 minus x squared over x squared dx, and let x equal to 3 sine theta, thus dx equals to 3 cos theta d theta. Okay, so when x equals to 3 sine theta, then x squared equals to 9 sine squared theta. Thus, this 9 minus x squared it will be equal to 9 minus 9 sine squared theta, and simplify that. Okay, and then you also know that 1 minus sine squared theta equals to cos squared theta, so you can put that in. Then you get 9 cos squared theta. Then you can square root the 9 straight away to 3, and square root the cos squared to just cos theta. Okay, so you have this 9 minus x squared, the square root of that, equals to 3 cos theta. And then we can put that in now. So let's continue. So integral of 9 minus x squared over x squared dx equal to integral of 3 cos theta over 9 sine squared theta, and then the dx, okay, dx is 3 cos theta d theta. We put that here, 3 cos theta d theta. So you can cancel out the 3 and 9, and then you will end up with the integral of cos squared theta over sine squared theta with respect to theta, which is cos over sine is the cotangent. So you put the cotangent squared theta with respect to theta. And here you can use the trigonometric substitution, okay? Cotangent squared theta equal to cosecant squared theta minus 1. Then you put that in, cosecant squared theta minus 1 d theta. And you can look up at the integration table for the trigonometric integrals of trigonometric functions. So if you integrate cosecant squared theta, you shall get minus cotangent theta. Then you integrate 1 with respect to theta, you'll just get theta plus the integration constant. Okay, so from that cotangent theta minus theta plus integration constant c, then you need to back substitute into the variable x. Okay, don't just leave this as your final answer because your original function is in terms of x. So you want to draw a triangle, okay, where this is your theta. So earlier you defined x equals to 3 sine theta. So sine theta equals to x over 3. So sine is opposite over hypotenuse. So this is x and this is 3. Thus the adjacent side of this triangle is 9 minus x squared. Okay. So from here you can convert the cotangent theta. So cotangent is what? Cotangent is 1 over tangent. So 1 over tangent theta minus theta plus c. So tangent theta is opposite divided by adjacent, x over square root of 9 minus x squared. So that is tangent theta, but if 1 over tangent theta is the other way around, then you just put that in. Okay, and then sine theta. So now here this is theta. So sine theta is x over 3, thus theta is the arcsine of x over 3. So put that in, arcsine of x over 3 plus c. So this is your final answer.